Hey there, science enthusiasts. Bill Nye here. Today we're diving into something totally awesome: energy. What is it? Well, imagine you want to run a race, or power up your video game, or even just blink your eyes. You need energy for all of that. Energy is the power to do things. It's the oomph, the drive, the ability to make stuff happen. Without energy, nothing would move, grow, or change. It's like the secret sauce of the universe, making everything tick and whir and zoom. Think about it. Energy is all around us in so many different forms. It's in the sunshine that warms your face. It's in the food you eat that gives you strength to play. It's in the electricity that lights up your room and powers your gadgets. Even when things seem perfectly still, there's often energy hidden away just waiting to be used. Understanding energy is super important because it helps us understand how the world works. From the tiniest atoms to the biggest stars, energy is the star of the show, making everything in the cosmos perform its incredible dance. Now, here's a mind-blowing fact about energy. It's called the law of conservation of energy. Sounds fancy, right? But it's actually a simple, super cool rule. This law says that energy cannot be created from absolutely nothing, and it cannot be destroyed into absolutely nothing either. Whoa, so all the energy that exists in the entire universe, that amount has always been the same and will always be the same. It just changes from one form to another. Think of it like building blocks. You can rearrange them to build a castle or a spaceship, but you still have the same number of blocks. This law is incredibly important. It's one of the most fundamental principles in all of science. It tells us that while we can use energy and we can transform it, we can never truly get rid of it. And we can't just magically whip up more energy whenever we want. This means we have to be smart about the energy resources we have. If we use up a certain type of stored energy, like the chemical energy in fossil fuels, it's not gone forever from the universe, but it might be changed into forms that are harder for us to use again, like heat that dissipates into the atmosphere. Consider a light bulb. When you flip the switch, electrical energy flows into the bulb. Let's talk about energy transformations, especially in what scientists call a closed system. A closed system is like a sealed box where no energy can get in from the outside, and no energy can escape to the outside. Imagine you have a perfectly insulated thermos flask with hot soup. That flask is trying to be a closed system for heat energy. In a truly perfect closed system, the total amount of energy would stay exactly the same forever, just changing forms within the system. It's like an energy magic show happening inside that box. Think about a wind-up toy car. When you wind it up, you're storing potential energy. We'll talk more about that later. In its spring. This is like putting energy into your closed system, assuming the toy itself is the system for a moment. When you let the toy go, that stored potential energy transforms into kinetic energy, the energy of motion, and the car zooms across the floor. Some of that energy also transforms into sound energy. You hear it whirring. And a tiny bit into heat energy due to friction in the gears and with the floor. Alright, let's zoom in on one of the most common types of energy you see every day: kinetic energy. The word kinetic comes from a Greek word meaning to move, so kinetic energy is simply the energy an object has because it's moving. If it's moving, it has kinetic energy. The faster it moves, the more kinetic energy it has. Also, the more massive an object is, the more kinetic energy it has, even if it's moving at the same speed as a lighter object. Think about it, a bowling ball rolling slowly has a lot of oomph, right? Imagine you're riding your bicycle, you are moving, so you and your bike have kinetic energy. If you pedal faster, your kinetic energy increases. If a big truck is rolling down the street, it has a huge amount of kinetic energy because it's very massive and it's moving. Even the wind, which is just moving air, has kinetic energy. Section 5, Stored Power, Unlocking Potential Energy. Now let's talk about another super important type of energy: potential energy. If kinetic energy is the energy of motion, then potential energy is stored energy. It's energy that an object has because of its position or its condition. It's like energy waiting to happen, full of potential. Think of a stretched rubber band. It's not moving, but it has potential energy stored in its stretched state. If you let it go, that potential energy quickly changes into kinetic energy as the rubber band snaps back. Ouch, be careful. There are different kinds of potential energy. One common type is gravitational potential energy. This is the energy an object has because of its height above the ground. If you lift a book up high, you're giving it gravitational potential energy. The higher you lift it, the more potential energy it has. Section 6. Feeling the heat. Understanding thermal energy. Let's turn up the temperature and talk about thermal energy. You might know it better as heat. Thermal energy is the energy related to the temperature of an object. But what is temperature really? It's all about how fast the tiny particles, the atoms and molecules inside an object are moving or vibrating. The faster these particles jiggle and wiggle, the more thermal energy the object has, and the hotter it feels. So a cup of hot cocoa has more thermal energy than a glass of ice water, because its particles are zipping around much more energetically. Thermal energy is everywhere. The sun is a giant ball of hot gas that radiates enormous amounts of thermal energy which travels through space and warms our planet. Section 7. More energy all-stars: chemical, electrical, and light. Beyond kinetic, potential, and thermal energy, there are other amazing energy all-stars lighting up our world. Let's start with chemical energy. This is a type of potential energy that's stored in the bonds of chemical compounds, the connections between atoms and molecules. Think of it like tiny springs holding atoms together. When a chemical reaction happens, these bonds can break and new bonds can form, releasing that stored energy. Food is a fantastic example. The calories in your apple or your sandwich are a measure of the chemical energy your body can use. Then there's electrical energy, which is a powerhouse in our modern world. Electrical energy comes from the movement of tiny charged particles called electrons. When electrons flow through a wire, we call it an electric current. This current can do incredible work, like powering our lights, computers, televisions, and all sorts of machines. We generate electrical energy in many ways, from burning fossil fuels, from nuclear reactions, from the kinetic energy of wind or water in dams, or directly from sunlight using solar panels. It's super versatile and can be easily converted into other forms of energy like light, heat, or motion. Section 8. Energy conservation in action: everyday examples. So we know energy can't be created or destroyed, only transformed. This makes conserving energy, using it wisely and efficiently, super important. Let's look at some everyday examples where we can see energy conservation principles at work and how we can be energy heroes. Think about your home. When you turn off a light switch as you leave a room, you're conserving electrical energy. That light bulb was converting electrical energy into light and heat. By turning it off, you stop that transformation, saving the electrical energy for when it's actually needed. Simple, but effective. Consider transportation. Riding a bicycle instead of taking a car for short distances is a great example of energy conservation. Section 9. Why bother with energy conservation? It's a big deal. So, after all this talk about what energy is, how it changes, and how we use it, you might be wondering, why is understanding and practicing energy conservation such a critically important thing? Well, it's a massive deal, folks, for a whole bunch of reasons. Firstly, many of the energy resources we rely on heavily, like coal, oil, and natural gas, fossil fuels, are non-renewable. That means once we use them up, they're gone for a very, very long time. Millions of years, in fact. Conserving energy helps these resources last longer, giving us more time to develop and switch to cleaner, renewable alternatives. Secondly, using energy, especially from fossil fuels, can have a big impact on our environment. Burning these fuels releases greenhouse gases like carbon dioxide into the atmosphere. These gases trap heat and contribute to climate change, leading to things like rising global temperatures, more extreme weather events, and melting ice caps. By conserving energy, we reduce the demand for energy generation, which in turn can lessen the amount of greenhouse gases pumped into our atmosphere. It's about being good stewards of our amazing planet Earth. Think of it as keeping our home clean and healthy. Furthermore, energy conservation can save you money. It's true. When you use less electricity, you pay less on your electricity bill. When you use less gasoline, you spend less at the pump.